So next we're going to look at our first profile, which is profile 0. And you can see by the naming convention it tells some of the details about what it is doing. Okay, it says it is the default MDT using GRE and then using PIM for customer multicast signaling. So if we go back to the diagram, what this specifically means is that we're going to use PIM as it comes in. Okay, so a PIM message is received from router 5. For example, this is the bootstrap router advertisement. Router 1 is then going to forward this to router 3, to XR3, and to XR1 over a PIM tunnel. Okay, so this PIM tunnel is going to be part of that particular VRF. So we're going to say for VRF-B, I have a multi-hop adjacency that goes over to router 3, and any PIM message that comes in here is going to go across that tunnel. Now the issue is I want to run multicast in MPLS, ideally when we're dealing with MPLS layer 3 VPNs. But the original problem we ran into is that there was no way to map a group address to the outgoing labels. Where originally the labels were one-to-one for every unicast destination you have, like 1, 2, 3, 4, you would have a label that corresponds to that. Okay, in the case of router 1, we want to take the packet in and then we want to send it 3 different ways. So originally we couldn't do this with MPLS, so we needed some sort of workaround. The workaround is to simply encapsulate the packet inside a GRE tunnel, and then we would use the regular PIM routing of the core in order to get the packet to its destination. So the key point being here is that when we configure profile 0, the overlay and the underlay signaling is PIM, the encapsulation is GRE, or in other words, what we are not doing, we're not doing any MPLS. Okay, instead what's going to happen is that the multicast packet is going to come in. Okay, it comes into the PE. The PE is going to take this, put it inside a GRE tunnel. Okay, the GRE destination is going to be some sort of multicast on the outside. And then inside, this would be the customer multicast, like our 228.888. Okay, and we'll see this on the wire that there is no MPLS in the encapsulation when we are doing profile 0. Okay, so first thing we need to know from profile 0 is, did address family identifier multicast distribution tree get used? So next thing we need to know is, what is the BGP state of the core? Okay, in our particular design, what I have pre-configured is that XR2 is a route reflector and router 2 is a route reflector. So what we need to do is to make sure that these guys have the correct address family identifier enabled. So let's go to router 2 and let's show run section BGP. And we have the address family IPv4 MDT. Okay, IPv4 MDT, this is the one that's needed for profile 0. Everything else is going to be using address family IPv4 MVPN. So this is effectively the legacy solution. Okay, so who are we activating in this case? We have router 1 and 3. So router 2 is peering to 1 and to 3. And it's peering to 11, 12, and 13. Okay, it's peering to everyone. Okay, next on XR2, who likewise is a reflector. Let's show run router BGP. And under the neighbors, it says we have address family IPv4 MDT, use address family group MDT. Address family group MDT says everyone is going to be a route reflector client of us. So router 1 is using MDT. And verification for this is going to be the show BGP, IPv4 MDT, all summary, or just summary. Okay, so notice that we're already receiving prefixes here. This is because I have this the solution pre-configured. But we are receiving routes from 1, from 3, 11, and 13, and then router 2 is reflecting routes to us. Okay, so our first step is established, which is the BGP peering structure. So this assumes that the other routers are peering back. Router 1, show BGP IPv4 MDT all summary. Okay, we're peering to both reflectors. Okay, so let's see, what is it specifically telling us here? For profile 0, it says you go under the VRF and you specify the default multicast distribution tree. And we're choosing a source-specific multicast address. Okay, SSM is anything that starts with 232. This means that the regular iOS routers, it doesn't actually show this in here, but there's another command that you would need, which is IPPIM SSM default. Okay, regular iOS or iOS XE doesn't process SSM until you enable this. Okay, so next let's look at the show run VRF. And we have VRF-B as in Brian. Okay, under the VRF it says the multicast distribution tree default address is 232.1.2.3. Okay, next we need to make sure that this address is the same on all of the PEs that are participating in VRF-B. And you do have to be careful if you're just copying and pasting the examples that are in that config guide. The iOS version is using different values than XR, so they wouldn't work unless you match up what the MDT defaults or the MDT data addresses are between the two platforms. Okay, so next let's look at this on router 3. Let's show run VRF. We're using the same value, 232.1.2.3. Okay, so let's actually take a step back with this. Let's go to router 3. We're going to remove this command. Show run VRF. Okay, we'll come back to router 3 in a second. Let's check on XR1 and XR3. Okay, the XR config is going to be different, of course, because it's different syntax. But the key here is that it uses under PIM, under the VRF, it uses this RPF topology command. And then under the route policy, it specifies what is the core tree. So again, I wouldn't necessarily recommend trying to remember or try to memorize these because there's so many different variations. This one here means that it's doing profile 0. But there's nothing in the config that says this is profile 0 other than just this one document that says combine the signaling in this manner, and then end result is that it's going to be profile 0. Okay, so we set the core tree PIM default, and then we should be setting the MDT default IPv4 address to be the same as what we were using under the regular iOS boxes. Okay, so this is under multicast routing and under router PIM. So let's see, what do we have under show run multicast routing. Under VRF-B, we have the MDT default address is 232.123. Okay, then hopefully same thing on XR3. Show run multicast routing. MDT default IPv4. Okay, also under PIM, show run router PIM, we have this RPF topology. If we show RPL, it says set the core tree to PIM default. Okay, so PIM is going to be translated into PIM effectively. Okay, if we look at it from router 1's point of view, we should see once these default MDTs are established, we're going to start to advertise, or actually let me take a step back. Before the MDT default can be established, we need to figure out what address are we sending the multicast packets out to. Okay, this is so we can join the PIM tunnel. So the PIM tunnel is going to be using that source-specific multicast address that we have, the 232.123, and the encapsulation for it is going to be inside GRE. So we would have the customer's traffic as multicast, the GRE header, and then a new outer header that says 232.123. This means that in the middle of the network, like on router 2, we should see an S, G entry for all of the PEs. So if we show IPM route for 232.123, 232.123, which is what I thought we were using, 232.123, router 2 doesn't see anything. Okay, the reason why is that router 3 stopped advertising this group address. So let's go back to router 3. Let's go under the VRF. And we're going to add the MDT default back. And there's a question here, can we use a specific default or can you use any address? It doesn't really matter what the address is as long as it's something unique, and it should be a source-specific address. You technically could change the SSM range, but it normally wouldn't make sense to do that. So anything that's the 232 range, you have to match it between all of the PEs. Okay, there's another question here. A route reflector in the topology would only affect the underlay multicast routing. It doesn't really affect it other than, oh yes, you're right. You're right. So a route reflector in the topology only affects underlay. So not the actual routing of the traffic, but you do need to take that into account for either IPv4 MDT or IPv4 MVPN. That you would send the routes to the reflector can reflect them on, but only if the AFI is enabled. Okay, so on router 3, we now specified MDT default again, and it's bringing up a new tunnel interface. Okay, this tunnel is going to be where we're forming the adjacencies to the other PE routers. So you can see pretty much immediately here that the tunnels come up. Now if we go to router 2, who was in the core, hopefully what we should see, well, it looks like that box is not being routed through. Someone else in the core, let's say XR2, let's say show and let me see, what was my command? Show mfib route is what I'm looking for. Show mfib route. And what we should see are the S, G entries. But notice that this is in the core of the network. So it says router 1 traffic is forwarding out these interfaces. It's coming in here. Flag A is where it's being accepted. And then flag NS and EG is the egress. Okay, so A to EG is what we're looking at. So the point of this being is that if you're doing MDT and you go to the core of the network and you do not see all of the S, G pairs, then you're not going to be able to forward any of the customer traffic. Okay, how do we do this though? This assumes that PIM is enabled everywhere. So if we look at, for example, on router 1 and show run include multicast or PIM, it's already been configured for multicast routing globally for the VRF, and then every interface we have PIM sparse mode on, including the loopback. SSM default, again, is needed because this is where we're sending traffic for that particular tree. Okay, next step is let's look at the routes. So if we look at the show BGP, IPv4 MDT all summary, we are receiving routes from the reflectors. Show BGP IPv4 MDT all. Okay, we see the routes that the PEs are generated, but now we want to know what specifically is inside there. Okay, the data that they're trying to tell us here is what is the group address that you want to join and who is the sender. So the sender is 3333, is router 3's loopback. It's going to be sending packets to 232.123. So if you want to receive this traffic, you should join the tree. Okay, since it's part of the same VRF, and I'm not exactly sure where that is encoded in here, that may be just the fact that it's based on the same distinguisher, that it is going to be included. So from router 1's point of view, if we simply look at the show IPM route, we should see 3 different endpoints. Okay, the incoming interface is the physical interface that is coming from the customer. So this here is going to the CE. The M VPN, these are going to the PEs. So they're trying to hop over the core, so the CE is connected to router 1. Router 1 then has PIM in the middle, and it's hopped out on router 3. So router 3 likewise would say packets come in, they go the other direction. Okay, the key here though is that these PEs have both routing tables. They have the global table plus they have the customers table. So what I mean by this is that on router 1, when we look at the show IPM route for VRF-B as in Brian, we would see those specific S, Gs, and it would say to get there you have to either come in the physical interface and then go out the logical tunnel, or you're going the reverse direction. You're coming in the tunnel and then forwarding out the physical interface. Okay, so now let's look at this from the customer's point of view. Okay, if everything is working, we should be able to go to router 4 and look at the show IP PIM RP mapping. Okay, we received the mapping information about router 5, so this tells us that the PIM messages that 5 is sending to 1 is sending somehow into the core. Those are popping out on XR1 back towards router 4. So to make sure that this works actually in the data plane, this is what you would need to check. Did they actually receive the mapping messages? Okay, now let's go ahead and send packets. So before we do this, we're going to do a packet capture on router 1. And I want to know what happens when the register messages go to the rendezvous point, the join messages go to the rendezvous point. What does that look like from the perspective of the core? Okay, so next let's bring up our viral box. And we want to capture on what particular interface? We want to capture on router 1's gig 2. So router 1, gig 2, traffic capture. Okay, next let's go back to our diagram. And we're doing a capture on all of these interfaces. Okay, so we saw that router 5 was the rendezvous point. Okay, next thing we're going to do is signal a join. So router 9 is going to join 229.123. We should see that this gets encapsulated inside of GRE. Okay, that PIM message is going to be routed based on the core tree, and it's going to get to router 1. Router 1 is going to remove the GRE header and just send the underlying IP packet. Okay, so that underlying IP packet is the IP multicast. Okay, 5 gets this, and it should put a star, G entry in, saying that if someone were to send traffic to 229.123, I'm going to go this direction. Okay, so on router 9, actually first on router 5, let's make sure that we don't have this state. So we'll look at the show IPM route for 229.123, no group is found. Okay, next I'm router 9. On gig 2.913, IP IGMP join 229.123. Check the same thing again on router 5, and hopefully we see now the star comma G entry. Okay, this means that the PIM signaling was working across the overlay. The overlay in this case is XR3 talking to router 1. So let's go ahead and look at our packet capture. This is router 1. And specifically, let's look for PIM. Okay, what we're looking for is a PIM join. And it should be coming from this link here, 913. So I believe it is this one here. To all routers, we're joining. What tree? No. Join prune. Okay, so this is making sure that we have not aged out. We have not aged out the S, G pair. So this is just a periodic refresh saying I want to continue to join that group. And let's try all the way at the bottom here. So join prune from, well, actually let's try this. Let's look for GRE. There we go. Okay, so we have the tunnel that inside we're talking PIM, but on the outside it's GRE. So again, the key point of this example is that we're not using MPLS. Even though MPLS is being used for the unicast layer 3 VPNs, with profile 0, since we're encapsulating into GRE instead of MPLS, there's no advantage in the core of running MPLS in this particular case. So we simply have to turn PIM on everywhere. It builds these GRE tunnels on demand, and then the customer's traffic is signaled over it. Okay, very last point for this example is we joined on router 9. We saw the state information was received by router 5. Let's now ping from 7 to 9. We should see that on router 5, we get the PIM register message. We start to receive the feed, and then we edit ourselves out of the path. So on router 5, let's debug IP PIM. We'll turn timestamps off and make sure that we're logging to the console at debugging. And then we're going to go to router 7 and just do a ping. So ping 229.123, repeat 100. Okay, 5 says that I'm adding or received a register. Okay, 2 different senders were registered. Router 7's loopback and router 7's connected interface. Again, this is because I did not specify the source or the exit interface from router 7. I was doing just a standard ping. Standard ping is going to source from all of your interfaces. So standard ping to the group. It says that we are adding the registered decap tunnel as accepting this the interface. Okay, so we received it in, and we are not throwing it away. Some reasons the rendezvous point would throw it away would be that if you don't have a route back to the source. So if this register message comes in and it says, I don't have a unicast route to 7777, then it would be dropped. Okay, the way we can verify this is show IPM route. Show IPM route 4.229.123. Does it have the entry installed? Okay, if not, it means there's something wrong with it. Okay, now we are actually joining the tree, because we know where the sender is. So we're sending a join packet to router 1 saying, hey, add us to the tree. Okay, I'm building the shortest path tree. And then eventually, we should see a prune to tell us you want to get off of that tree, okay, which was this here. For neighbor 10155, I'm sending the shortest path tree prune saying that I wasn't really in the data plane for 7 to get to 9. I would prefer, instead of you going this way and then back, I would prefer you just going direct between the two of them, or whatever the other shortest path is. And this is why you either need to debug on the rendezvous point or look at the packet capture, because once the switchover occurs, if we show IP mroute for 229.123, right now it looks like it's not working. Okay, this is saying I don't know where the packets are coming from. If packets were to come in, we would forward them out gig 2.15. This is saying I do know where the packets are coming from, but if they come in, don't forward them anywhere, drop them. So a functional multicast result would be the incoming interface and outgoing interface of the SG pair should both be populated, meaning that it's actually forwarding the packets. So for example, if we were to look at router 3, who is in the path for the data plane, we would want to know two things. Okay, what's happening on the overlay, which is the customer's network. So show IP mroute for VRFB. It says if the packet comes in gig 2.37, which is towards router 7, forward it out the tunnel. Okay, what is tunnel 0 though? If we show interface tunnel 0 is a multi-point GRE tunnel, okay, multicast GRE technically. And if we show run interface tunnel 0, there's no configuration. Okay, if we go to interface tunnel 0, it says you can't use that. It's being used by the multicast VPN. Okay, so we saw based on the overlay routing table, packets are coming in, forward them out the logical tunnel. Okay, where's the logical tunnel going though? If we show IP mroute and look at the underlay, it says when these come in, if 3333 is coming locally, you need to forward it out these interfaces. So effectively what we would see is for every unique VPN between these 4 devices, we would have 4 S-G pairs when we're dealing with profile 0. Okay, so again, profile 0 here is when PIM is doing the underlay signaling, which just meant that every device in the middle of the network is running PIM. PIM is running on the overlay. This is what we're doing here. Okay, so we're forming adjacencies, and if we look at the show IP PIM neighbors on router 3, and look at the show IP PIM VRFB neighbors, this is the difference. We now see across the tunnel, we're forming PIM adjacencies. So PIM on the underlay, PIM on the overlay, and then the encapsulation of the actual packets are the GRE tunnel, which is going to look like this. So the outer IP address is what we chose as the MDT default address. The inner packet is going to be whatever the customer multicast is sending.